I just started watching this video, and maybe about 3 or 4 audio seconds were just dropped at the beginning, so I'll have to try to remember what I said and fill it back in. I know I keep saying this. I keep saying that I keep getting distracted from where I'm going, but it's true. It's true. I can't. Every time I try to go along one path, something comes up, and a big long diversion occurs. In fact, I've taken note of some of the diversions. Just I think it was yesterday. I wanted to just make a quick mention. After that thing about the automatic constructor thing, I wanted to make sure that you understood that's just a hack thing, and I wouldn't, you wouldn't want to use that sort of thing in production code. It's just I thought it was a cute trick, You might use it for your own code if you don't plan on distributing it. If it speeds things up for you, that's fine. As long as you're aware that you gotta take it out eventually if you want to make that commercial code. Although commercial code, what's out there is also so poorly designed and obviously badly written that you probably shouldn't worry about it too much. Well then, after that, I was working on my little hex editor, and I added some mouse support. What am I on here? I keep going back and forth in the configuration. Turn that on. I'm trying to wiggle this RPC stuff into view. Other things jumping away, as I said. Common, Windows, HEXEDIT. I did make an installer for it, but it's far from complete. But what I was all excited about was the fact that I could use the mouse wheel. I've never, you know how to use it. I'm using the mouse wheel right now to do this. I've never written any code for that. There's most of the common controls support the mouse wheel, but I had to take over in the case of the HEXEDIT, I have to take over the scrolling stuff, so I have to handle the mouse wheel. And also the keyboard, the page up, page down only. I'll show you quickly what I mean. So mouse wheel, get a big file. Here's a big file. This file is the file that has been throwing me off in tangents all over the place. You'll notice that it hasn't even loaded up yet. And you might think that that's pretty bad programming, right? Well, it turns out that of all the programs that I have, this text editor is the only one, at least that I've written, that can open that file up. Notepad, well, you'll see later, can't. This MS-Dev could open it up as binary, probably as text as well, because It's one of those editors that handles all of the editing itself, you know, unlike using a built-in control. It's UTF-8, right? That's the signature for UTF-8. And here's my keyboard support, scrolling down, scrolling up, the thumb dragging, and the mouse wheel, and everything's great. The reason I can do that in this file so easily is because this file doesn't, even though it loaded in all the data into memory, it didn't load it all into the edit control. If I take that same file and I try to open it up with my notepad, I figured no problem, I loaded up easy. Actually, what happened was it crashed, and it was a silent crash. For the release build has a try catch around the loading thread. It's called log file. Now, as a matter of fact, at this point I could quit and say that the file is too big. I know exactly what the limit is now. And I could load this into this program, but not if it's compiled for Unicode, because it takes twice as many bytes to represent the data in the edit control, and this file is nearly 1 gig, right? 775 megs, and it crashed, and crashed because LocalAlloc failed. Okay, LocalAlloc failed, and then I looked at my code and I found a silly bug. This is something you should be aware of too. I said this once, I'm sure you don't remember, but I remember saying it. What a dumb function, you know, MulDiv. What it does is it multiplies a number by something and then divides by another number. Yeah, I'll show you. Eventually a box is going to come up. Not that box. You ever heard of this MulDiv? Int I equals 23. Sorry. I might have another variable. Y is 23. Int j equals I MulDiv. MulDiv. It takes 2 parameters. Oh no, 3. Okay. I numerator. Suppose I want to multiply this by 4/5. I mean 5/4. That's right. In this case, where it would increase, and then print it out. I can just print this out. I don't need I, I'll use 23. How's this guy doing? No, oh, it died right now. It's the wrong version. So the new version prints out a message. It's equal to, can you guess? %B. Well, if it does what it claims it's going to do, then it's going to do 23 times 5 quarters, right? And 23 times 5 quarters, maybe I should make it something that's easy to work out. 24 is divisible by 4, right? By 4? 8, 7, 28. Okay, so this one would end up being 7 times 5, which is 35. Right? 7 is 4 times 7 is 28, so that turns out to a 7. 7 times 5 should give 35. Pretty dumb function, right? Of course, of course. There's so many things going. Some of them are only compiled with Unicode, and some will only compile with non-Unicode. I gotta get rid of some of these things that are piling up. I didn't get rid of this yet. There was something in here called time, and I changed that and reduced it down to a template project for RPC crime project. Now when I run this, it should come out to 35. Okay. Now you're probably thinking, well, why don't you just do, this, multiply, and then divide. That's what I said. That was my comment. Come up with the same answer. Well, you probably guessed by now, since I've been talking about memory limits and things crashing, that there's a reason why they have such a function. The reason why they have such a function called MulDiv, and that has to do with the reality, right? That on a computer, this expression isn't always equal to, A times B over C is not equal to MulDiv. In general, because there are limitations, right? One of the limitations, or the main reason for this function is the limitation. Well, it's a main reason, but one of the limitations is if this number causes a wraparound, right? Then you don't want to multiply by 5 first. Right? If this would say this was int max over 2, right? Then multiplying by 5, even though the result will be less than much less than int max. If you do it in this order, you won't get the right answer. I'll just not equal equals Well, int max, I'll just write out a number. Int max is approximately 1 million. Sorry, 2 million. 2 billion, sorry. 9 zeros. So there's approximately a half of int max, and same thing here. Just copy the number. Okay. Now first let's just try it like this and see what we get. Well, multiplying this number by 5 is going to give us something negative in terms of ints, right? And so we're going to get a negative value in the end. Now, yeah, see, well, it's warned me, but you wouldn't know in general if this was a variable. I use I here. I lose the warning about this. Lose all my warnings, and everything's fine. But it's not going to be the right answer. No. It did come out to the right answer. Now, how did it come out to the right answer? Because the order should be this times I times 5. The right number is that. That's 9. What if I do this? I times 5. That's got to come out negative. It told me. Maybe it's smart enough to see, the I there. Oh. 1, 2, 3, 4, 5. Oh, it's a smaller number, honestly. It still came out positive, strangely enough. But it came out smaller. So this number then must have been the wrong answer. And that's what happened with Notepad#. The answer came out positive, but it was an unsigned value to begin with. And but it was smaller than what I started with. Oh yeah, this is definitely the one. No. 1, 2, 3. Oh, it is wrong. It is wrong. It's off by a factor of 10. If I do MulDiv, and you don't notice it, it looked like it was correct, then I'll get the right answer, which should be 1, 5, and then 0, something like that. 5/4 of 1 billion is 1 billion plus another quarter of a billion, right? So it should be 1, 2, 5, and then zeros. Oh dear. This is one of the diversions. See, it got me thinking about this MulDiv. So I used the MulDiv to do the multiplication. I came out with the right answer, and I was trying to do a realloc. And I thought the bug was with the MulDiv. Well, that was one bug. See, that's the correct answer. So I fixed that bug, and then it crashed because it couldn't allocate the memory. And I got with Notepad, you notice it didn't open that file. If I try it with the regular Notepad, you get the same thing, except this one prints out the thing that I'm now printing out, which is that the file is too big for Notepad. Okay, now I thought these days were over with the 4 gigs and all that. This isn't even 1 gig, it's only 782 megs. But no, Notepad can't open it for the same reason I can't open it, because the limit, and I found this out by the fact that I was able to allocate more than, I was able to allocate half of the amount I needed, and then I used this MulDiv and I kept going down until I was able to allocate again some more, which I did, and read in a little bit more, and so I was able to read a little bit more. I think in fact it was 5/4 of this number of wide characters, and that's the limit. And I figured, well, that must be the limit of the local heap, right? Because this thing, Notepad, uses local heap memory. It's documented somewhere. I'll never find it. I used to have all those things in my favorites. But if you look up the help for what's the message? EM get handle or something? Something handle. Oh, not EM. Here. It tells you that the handle is a local heap handle somewhere. See? Local unlock. Application returns the value of an H local and use LocalAlloc to get a pointer, right? So now I've determined the max and total extent of the local heap, correct? Wrong. So they're such liars, these people. It's not that. That's not true at all. Same thing for, I haven't tried it, but I'm certain the same thing is going to be true for the global heap. I mean, the thing that the heap that is involved with malloc. See, I've even got this program set up here. The reason why I was able to open it in my hex editor thing, all of the contents, was because I just opened the contents to try to display it or anything, and so I only required this many bytes. Here's a thing. You know that address to H instance thing that I went over a couple videos ago with the picture? Where were we? We were looking at that. Just here. No, not that. That's a directory. Right? The universe of a process and walking the virtual memory space. And I explained how that address to H instance thing works by going through and finding all of the regions of memory that have an associated file, and so therefore those things, if it's code, that would correspond to modules that have been mapped into memory. Well, I think like in the same tutorial, I also mentioned something about my heap walking thing. You know, I've got that heap walk thing that if I turn on a certain flag, I get a heap report about the dynamic heaps. Just put a breakpoint here. Hopefully it's turned on. Although I've now added a function so you can just get it out as a string. And if you want to print it, that funny character has to change, but whatever. I just want to see if I'm printing it out in here. Believe it or not, I found a bug in my heap walker. It's not just a minute. That's a new text. I started getting tired of seeing it, so I just moved option on default to off. New text. No, I'm staring right at it. Dump heap. Oh, where are they? Okay. View text. Turned it off or something. Wait, no, I just opened this. I probably turned it off accidentally as I was testing. Well, it's in here. In here, called generate heap report. I think it's in here. Right. Why is there no semicolon here? Oh, that's the function. Okay. There's a call. Dump process heaps. Oh, it's all commented out. Okay, that's why. Because I was trying to fix it. Now, this is and I think I need to set this. I think I need to set a flag, but I'm not sure about the flag. See that number, CDW number heaps, is the number of elements in this array of heaps. But then there's an inner walk for each heap. Each heap has sections, and I wasn't walking through them all. I just happened to notice that. And in fact, I noticed that just before writing that function address to h heap, which converts just like that other thing does, converts a given address to either to one of the heaps, tells you which heap it's in, but with using the same kind of walk, right? Remember the last heap, walk through all the regions in that heap, right? Until you pass the pointer in the last heap that you had is the heap. That happens to be corresponding to the passed in pointer. F7. Okay, here we are. I'll show you one of the ones I would have missed. and it's an important one. Oh, not yet. I have to run my program. Okay, so I wanted to find out where this local heap was, because in my mind I was thinking, okay, maybe I can resize the local heap, and you probably can, but I don't know how you can tell the rest of the world that you've done it. Alright, generate heap report. That just returns a string which you can print out, so I can print this out as I run the program instead of looking in this little window. Then what I do is I use LocalAlloc to make a little piece of memory, and I call my address to AP, and it will tell me the handle of the handle value, like the handle to heap, not handle to memory, although it turns out to be the same thing. Okay, here I've printed out the heap report, same as you saw before. And now I'm printing out something returned from LocalAlloc. lmemfix returns you a pointer that doesn't need to be locked. It's already a valid address to write to. And then something from malloc. Okay, so we'll have a pointer to a local and a pointer to a global heap entry. Okay, so the locals are at this area, and the globals are in this area. Now, if you look through the list here, it's pretty obvious that heap 5 is the global heap, right? 13F, and where's this 2AE? I know where it is. The first one, entry number 1, 2E0 to 3E0. See? Nothing to it. So I want to write a simple function to tell me which is the local heap, and then maybe resize it. So now this here, now I'm just using my the same method I used to find an H instance and stuff into it if you like. I get the process heap, start walking through them, and I look for an instance where the pointer is between the region's first and last block. Okay. And according to the help, this points at the first byte of memory that is not readable in the region. Okay, I'll just step back out. And what I get back is 2E000. Surprise, surprise. So the local heap is located here, and I try to compute the size, but I'm not sure about this size because what I'm about to do here. I must be computing it wrong because of the following thing. Alright, now I unlock the address. Now I'm trying to find out where the global heap is by just doing another malloc a little bit. Call that same function, which walks through, and print out where the global heap is and its size. Global heap is here, and this is its size, which would be 20 megs. Alright, not very big. Okay. Now this number, unless I'm insane and I can't read, is 50 million, correct? There's a 50 followed by 1, 2, 3, 4, 5, 6. 50 million bytes. Much, much larger than the size of the local heap, right? At least according to my possibly flawed function. Well, I'm going to call LocalAlloc, which was the function that failed in Notepad³, but I know it succeeded for a number larger than that. It succeeded for that great big, this number, 700 million, 800 million, so it ought to be able to do it for 50 million, and then I'm wondering, well, what's going to happen to that local heap, right? If you look at that report, I don't think it can grow anymore by that amount. Alright, well, look at the number I got back. Oh, sorry, I haven't locked it yet. I'm going to lock the memory, and that gives me this number. And now, just to ensure that that is valid memory and that it is that big, I'm writing a byte at the very last byte in this 50 million byte array, setting that to 0. No crash. Okay, so it's 50 million bytes big. Now, according to this same function, the local heap. Oh yeah, the other thing I'm printing out is the index. You notice, did I print it out here? No. Oh yeah, I did. The index, these indices are the number, the heap number in this list. Well, you'll notice that where I just printed out doesn't leave me in the local heap. It's printed here. It's put me in the 4th heap, whose size is this 21 megs, and I've allocated 50 megs in that region. So it doesn't make any sense. Sometimes it comes back with index 3. You see what I'm saying? Like something weird is going on. So what I want to do is print the heap report again. See what happens. See if anything changed. That's what all these things are here for. To make a nice separator. Print it out again. Now, indeed, the heap 5 hasn't changed from what it was. Go back. See? Same thing. Heap 4 is certainly based at the right spot according to the number that I have. Here's my locked thing, 142 something. The byte, the pointer itself is gone, but it was nearly that. I printed it out anyway, I think. In this region, right? Which starts here. Before, oh sorry, it would be right here. Where's my pointer? No, I didn't print it. But it doesn't matter. It's it is within that region. Now 14 something something is actually bigger than entry 5, really. The 4th heap is further along in memory than the 5th heap, turns out. So it's possible that somehow it's glued these two together or something. I don't know. You know, if it's extended the global heap. Sometimes it comes back with entry 3, which is currently this one, but also with a big value. So these things get changed and shifted around. But one thing's for sure, am I doing it here? If I do this a little LocalAlloc again, let me add it here. I can just print it out like I did with this. I believe, I'm not certain, but I haven't tested this, that the little local heap is still the little local heap. I could do this, or where's the mount? Trying to look around it. The microphone's in front of my face. Where is it? I have malloc and printer. Oh, this one. Okay. This doesn't require any variables. So print out two little numbers. I mean little allocations. And it's my guess that those will be consistent with what they were originally. No, sorry. I expect this one to change and this one to remain the same. Because I think if the amount is larger than the local heap size, it just takes it from the global heap. I mean, that would be the logic. C, 2, 4, let's see what it was originally. It's not the same. You'll notice also all these extra entries. Okay, first time. Here I just print the report. I'll stop after this. You see how easily one gets diverted. 24, 9 something something and 16, 8 something something. And at the end, oh, almost the same. Okay. So the global heap didn't get used up. And where did the local heap go? Where did it relocate itself to temporarily? Well, let's go second first. Index 3, see? So it went to index 3, but to see about index 3, I can't look this way. I gotta look down. You see that these are the ones that I was missing before. Heap number 320, 321, entry 3. For each heap, it has heap entry. So heap 0 is this. Heap 1 has 2 entries. Heap 2 has 2 entries. Heap 3 has a whole, just 2. Did it change? I don't know. I'll check that in a minute. But look at this file. It's added all these extra entries. And the last entry is what it was before. I see. I wasn't seeing these before because I had that stupid bug with the counter being wrong. Okay, 16A, and then but previously it was the same. Oh, it has a whole bunch. No, it's the second one. Sorry, I can see that thing. It still has a whole bunch. Look at that. and it's the same. But the local heap went to index 3, and then when I did the last allocations, right, I got 249 something, which is not index 3. That would be it's supposed to be 0. Yeah, it is 0. From 23 to 33 with 4 trailing zeros. That's within that region. And this one hasn't changed. So therefore, I don't know about local and global, but I can tell you one thing. That the local heap, to say the local heap is a misnomer, because when you call LocalAlloc, that might wind you up in any heap. Could be anywhere. It might be in the global heap, although I've never seen it happen. I've seen just 3 and 4. But I suspect that one day it'll work into 5. It just tries to do the allocation. So that's one thing I found out. Now I'll go on with more of my diversions. So here I am, LocalAlloc cheats. And I found that out from Notepad3 bug, which originally started by my getting curious about that MulDiv function, which saved the day in terms of numbers, but overran the memory, which led me to investigate the local heap, which made me find a bug in the heap report generation, which led to me making a function similar to address to HEXEDIT, which returns addresses to heaps, handles to heaps for addresses, and I never got to the point of trying to actually resize the local heaps in order to make that allocation succeed. Next, I'll continue on without delay onto all of the other funny things. Actually, I finished all of that part. XML view. See you. Is the next topic.